everyone, and welcome back. We're diving into something pretty mind-boggling today. Black holes. Those mysterious objects out in space, where gravity is so strong that nothing, not even light, can escape. Our guide for this deep dive is an article called The Mysteries of Black Holes, Unveiling the Universe's Most Powerful Phenomena. And I'm already fascinated, and I think you will be too. What happens if you get too close to a black hole? Well, let's just say it's not a pretty picture, but we'll get to that later.
It definitely involves some stretching. But before we get to the dramatic demise, maybe we should start with the basics.
Yeah. So what exactly is a black hole? I mean, I've heard the term, but it's still kind of hard for me to wrap my head around.
Well, imagine a region in space where gravity is so strong that absolutely nothing can escape its pull. It's kind of like a cosmic vacuum cleaner. But instead of dust bunnies, it's sucking in light and matter. And get this, Albert Einstein predicted these things decades before. We even had the technology to prove they existed.
Wow, talk about being ahead of his time. But how do these cosmic vacuum cleaners even form in the first place?
It all starts with the death of a massive star. These stars are like giant furnaces, constantly burning fuel to produce energy. But even stars have a lifespan. When a massive star runs out of fuel, it can no longer support its own weight, and it collapses under its own gravity. Sometimes, this collapse results in a supernova, a spectacular explosion that blasts the star's outer layers into space. And for the really massive stars, the collapse doesn't stop there. It keeps going, squeezing all that matter into an incredibly tiny space, forming a black hole.
So it's like a star's grand finale, but instead of fireworks, we get a black hole. That's intense. But if all that matter gets squeezed into such a tiny space, what happens to it? Does it just disappear?
Not exactly. It gets compressed into what we call a singularity, a point so small it practically has no size, and all the star's mass is concentrated there. Our current laws of physics kind of break down. When we try to describe what happens at a singularity, it's mind-boggling to think such a thing could even exist.
Yeah, I can see why scientists were hesitant to believe in black holes at first. But we know they're out there, right? And we even observed different types of black holes.
Exactly. We have stellar black holes, which are the most common type. They're formed from the collapse of a single star. These are typically about 10 to 20 times the mass of our sun. Then there are the supermassive black holes, the real heavyweights lurking at the centers of galaxies, including our own Milky Way. These behemoths can be millions or even billions of times heavier than our sun. Imagine the gravitational pull of a billion suns concentrated into a single point. It's almost incomprehensible.
That's just, wow. I'm struggling to even picture that. It makes our sun seem like a grain of sand. So we have these stellar black holes from single stars and these massive ones at the center of galaxies. Is there anything in between?
There is. We also have intermediate black holes. Think of them as the middle child of the black hole family. They're thought to form from the mergers of smaller black holes. Still massive, but not quite on the supermassive scale. They're like cosmic Pac-Man gobbling up other black holes to grow bigger and bigger.
That's a fun way to think about it. But I imagine it's not quite as simple as Pac-Man gobbling up dots. What actually happens when black holes merge?
You're right. It's a much more complex and dramatic process. It's a cosmic dance of gravity with space and time, being warped and stretched in incredible ways. It's one of the most energetic events in the universe.
Okay, so black holes aren't just sitting there passively. They're interacting with each other, merging, and who knows what else. This is all incredibly fascinating. But I have to ask, what would happen if, say, a spacecraft got too close to a black hole? What would that look like?
Well, let's just say it wouldn't be a smooth ride. As you approach a black hole, the difference in gravitational pull between your head and your feet would become extreme. You'd start to feel stretched like taffy.
Okay, hold on. I'm trying to wrap my head around this. You're saying that a black hole actually distorts the fabric of reality itself? That's incredibly profound. So I'm getting stretched. What happens next?
The stretching gets more and more intense the closer you get to the black hole, a process we call spaghettification. Eventually, you'd be stretched into a long, thin strand of, well, you get the picture.
So I'd become a human noodle. I'm not sure I buy it. Surely there's got to be a limit to how much stretching a body can take, right?
It's a rather dramatic illustration of the extreme tidal forces at play near a black hole. But the basic principle holds true. And it's not just about stretching. There's also time distortion to consider.
Wait, time distortion? What does that mean?
Imagine you're watching a spacecraft fall into a black hole from a safe distance. It would appear to slow down as it got closer to the event horizon, the point of no return. In fact, it would seem to freeze in time right at the edge.
Wow, so time slows down near a black hole. Like a cosmic pause button.
That's incredible.
But what about the people on the spacecraft? What would they experience?
For them, time would seem to flow normally, at least initially. But things would get very strange very quickly as they got closer to the singularity.
So we've got stretching, time distortion, anything else I should be worried about?
Well, we haven't even touched on the possibility of wormholes yet.
Wormholes. Now that sounds like something straight out of science fiction. Are you telling me black holes could be portals to other dimensions?
That's where things get really speculative. But there's a concept called wormholes, theoretical tunnels through space-time that could potentially be created by certain types of black holes.
This is all a bit much to take in. We've got black holes warping space and time, spaghettifying anything that gets too close, and maybe even acting as portals to other dimensions. I don't know about you, but I'm finding all this incredibly fascinating. Black holes really are something else.
They truly are one of the most mysterious and intriguing phenomena in the universe, pushing the limits of what we thought was possible. And believe it or not, they're not just agents of destruction, they also play a crucial role in the evolution of galaxies.
Wait, really? I thought black holes are all about sucking up everything in their path. How can they help create things?
That's a common misconception. While their gravity is incredibly strong, black holes also act as cosmic architects, shaping the galaxies around them. Think of the supermassive black holes at the centers of galaxies. They attract vast amounts of gas and dust, which swirls around the black hole, forming what we call an accretion disk.
So instead of just sucking things in, they're also creating these swirling disks of matter.
Exactly. And as this material falls toward the black hole, it heats up to incredible temperatures, releasing tremendous amounts of energy. This energy can then influence star formation and the overall structure of the galaxy.
Wow, so black holes are both creators and destroyers. That's pretty amazing. And I remember you mentioning something about black holes not lasting forever. What happens to them in the end?
Well, even these seemingly eternal objects are ultimately bound by time. It's a concept called Hawking radiation. Essentially, black holes slowly leak energy, and over vast, unimaginable timescales. This can cause them to evaporate completely.
So you're saying that even these cosmic giants eventually fade away. It really puts the scale of the universe into perspective, doesn't it?
It does. And it makes you wonder about the bigger picture, right? What happens to everything else in the universe? Well, there are some fascinating theories about the ultimate fate of the universe.
Okay, now you've really got my attention. Let's dive into that, shall we?
One scenario that cosmologists have proposed is called the Big Crunch, where the universe's expansion eventually slows down and reverses, ultimately collapsing back in on itself like a giant cosmic rewind.
So everything goes back to the way it started. Does that mean we'd end up back at the Big Bang?
That's the general idea. And in this scenario, black holes would play a major role. As the universe contracts, they'd gobble up more and more matter, eventually merging with each other until there's just one super-duper massive black hole that encompasses everything.
Wow, that's kind of a bleak ending. It's like the universe eats itself. Are there any other, maybe less dramatic possibilities?
Another scenario is the Big Freeze. In this scenario, the universe keeps expanding forever, getting colder and more spread out over time. Eventually, stars burn out, galaxies drift apart, and the universe becomes a vast, cold, and empty place.
That sounds pretty lonely. What happens to black holes in this scenario? Do they just keep growing forever?
Actually, even black holes eventually meet their demise in the Big Freeze scenario. Remember, Hawking radiation.
Yeah.
Over incredibly long timescales, that slow leak of energy causes black holes to evaporate completely.
So in the Big Freeze, even the mightiest black holes eventually fade away. It's almost poetic in a way. Everything returns to nothingness.
It is a reminder that change is the only constant, even on a cosmic scale. But let's step back from the end of the universe for a moment and talk a bit more about those theoretical wormholes. They capture the imagination, don't they?
They really do. The idea of traveling through a black hole and ending up in a different part of the universe, or even a different universe altogether, is mind-blowing. But are wormholes even a real possibility, or are they just a product of science fiction?
Wormholes are still very much in the realm of theoretical physics. But the idea comes from Einstein's theory of general relativity. According to the theory, it's possible that certain types of rotating black holes, known as Kerr black holes, could create these tunnels through space-time.
So if these Kerr black holes are spinning, they could warp space-time in a way that creates a tunnel. Where could these tunnels lead?
That's the big question. And the answer is we don't really know for sure. Theoretically, wormholes could connect distant parts of our universe, making it possible to travel vast distances in a shorter amount of time. Some theories even suggest that wormholes could connect to entirely different universes.
Okay, that's just whoa. I'm picturing a cosmic subway system with black holes as the stations and wormholes as the tunnels connecting them. You hop on a wormhole express and zoom across the universe in the blink of an eye.
It's a fascinating thought experiment, isn't it? But there are a lot of challenges and unknowns when it comes to wormholes. For one thing, we don't know if they're stable. Some theories suggest that wormholes might collapse as soon as they form, making it impossible to travel through them.
So my cosmic subway system might be more like a cosmic roller coaster
Yeah.
with sudden twists and turns and the possibility of getting stuck upside down.
That's a good analogy. And then there's the question of how we would even create a wormhole in the first place.
Yeah.
It would require manipulating immense amounts of energy and gravity, something that's far beyond our current technological capabilities.
So maybe not booking a trip through a wormhole just yet. But it's still incredibly exciting to think about the possibilities. Black holes, wormholes, the fate of the universe. This deep dive has been a wild ride. And I have to ask, why are we humans so obsessed with black holes? What is it about them that captures our imagination?
I think it's because black holes represent the ultimate unknown. They push the boundaries of our understanding, challenging us to think beyond our everyday experiences and confront the vastness and mystery of the cosmos.
I think you're right. Black holes are like a giant cosmic question mark, daring us to unravel their secrets. But they're not the only things out there that spark our curiosity. There are so many other incredible objects and phenomena in the universe just waiting to be discovered.
Absolutely. And the more we learn about the universe, the more we realize how much we still don't know. It's a humbling and inspiring experience.
Well said. And speaking of being humbled and inspired, I can't help but think about how our understanding of black holes has evolved over time. It wasn't that long ago that they were considered to be purely theoretical objects, the stuff of science fiction, and now we're observing them, studying them, and even starting to unravel some of their mysteries.
It's a testament to the power of human curiosity and our relentless pursuit of knowledge. It makes you wonder what other incredible discoveries await us in the vast expanse of the universe.
That's a great question, and one that I think we'll be pondering for a long time to come. But for now, I think it's time to wrap up this deep dive into the mysteries of black holes.
I agree. It's been a fascinating journey, and I hope our listeners have enjoyed exploring these cosmic wonders with us.
I'm sure they have. And before we go, I want to leave everyone with one final thought. If black holes can evaporate over vast timescales, what does that tell us about the nature of time itself? Is time truly linear, or is it something far more complex and mind-bending than we can currently comprehend?
Yeah, that's a question that really makes you think. It's almost like black holes are challenging us to reconsider everything we thought we knew about the universe.
They certainly do challenge our assumptions, and that's what makes them so captivating. They force us to confront the limits of our knowledge and to embrace the mystery of the unknown.
I completely agree. It's both humbling and exhilarating at the same time. We're just starting to scratch the surface of understanding these incredible objects. And who knows what other mind-bending discoveries await us. That's the beauty of science, isn't it? It's a never-ending journey of exploration and discovery. And black holes, with their extreme gravity, their ability to warp space and time, and their potential connections to other dimensions, are leading us down some truly fascinating paths.
Speaking of fascinating paths, I can't resist circling back to those wormholes one last time. What are some of the biggest challenges scientists face in trying to understand and potentially even harness the power of wormholes?
One of the biggest challenges is the issue of stability. As I mentioned earlier, some theories suggest that wormholes might be inherently unstable, collapsing almost as soon as they form. That would make traveling through them rather difficult, to say the least.
So my dream of hopping on a wormhole express to a distant galaxy might be a bit premature.
It might be, but there are some theoretical solutions to the stability problem. Some physicists believe that exotic matter, which has negative mass and energy, could be used to prop open a wormhole and make it traversable.
Exotic matter. That sounds even more mind-boggling than wormholes themselves. Does this exotic matter even exist?
That's another challenge. We haven't actually observed exotic matter in the universe yet, although there are some tantalizing hints from particle physics experiments. But even if exotic matter does exist, harnessing it and using it to create a stable wormhole would require technology far beyond anything we can imagine today.
So, while the possibility of wormholes is incredibly intriguing, it seems like we're still a long way from being able to actually travel through them. But hey, that's okay. Sometimes the journey is just as exciting as the destination, right?
Absolutely. And the journey of understanding black holes and their implications for the universe has been an incredible one so far. And it's far from over.
Yeah.
There's still so many mysteries to unravel, so many questions to answer.
Well said. And I think that's a perfect note to end on. We've covered a lot of ground in this deep dive, from the basics of black holes to their potential role in the fate of the universe. We've talked about spaghettification, time distortion, Hawking radiation, and even the mind-bending possibility of wormholes.
It's been a whirlwind tour of some of the most extreme and fascinating phenomena in the universe. And I hope it sparked a sense of wonder and curiosity in our listeners.
I'm sure it has. And before we sign off, I want to leave everyone with a final thought to ponder. Black holes, with their extreme gravity and their ability to warp the very fabric of space and time, challenge us to reconsider our place in the cosmos. They remind us that we are part of something much larger and more mysterious than we can fully comprehend. And that's a pretty amazing thought, isn't it?
It is indeed. So keep looking up, keep asking questions, and never stop exploring the wonders of the universe.
Thanks for joining us on this deep dive into the mysteries of black holes. Until next time, keep exploring.